Okay, solving for unknowns. So they've given us this expression. And what this really means is that the left side is equal to the right side. But the whole idea or the goal of this expression will be to isolate for x. Okay, so this is the left side and this is the right side. And right now it says they're equal, but it doesn't give us a lot of information about this unknown here. This is our x. Okay, so the goal will to get x by itself. Okay, so this x here we want to get by itself. And a lot of times when we talk about the terms in these equations, these are known as our variables, okay, and these are known as our constants. So we're going to figure out which ones are like terms and unlike terms. And our variables that have exponents that are the same, okay, so let's put these guys in blue. These two are like terms, okay, and
this is exactly what we're doing.
Yeah, our constants, these two are like terms. So what we're going to do is we're going to put all of the like terms on one side and all of the other like terms on the other. So though we're not used to seeing it usually, I'm actually going to move all of the variable equations to the right and all of the constants to the left. So they'll end up on the left side and the variables will end up on the right side.
So is it always that way, where the variables go to the right?
It doesn't actually matter. You can do it whatever way you want. In fact, do you want me to do it both ways so you guys can see? Let's do both.
Sure.
Yeah, might as well, right? Okay, so we'll split the screen in half here. So on the first one, I'll do it, oh my, that's the wrong one. Okay, over here, we'll move everything to the right. So I'll rewrite it, 8 minus 2x equals 10 plus 3x. So we'll do one step at a time. The first thing I'm going to do is I'm going to move this negative 2x. So I want you to think of that as a negative. And we're going to move it to the other side. So when I move negative 2x to the right, what will it become when I move it over? Do you know? It's the opposite operation. So what's the opposite of a negative?
Positive.
A positive. So instead of being negative 2x on the other side, it's going to be
2x.
Yeah, positive 2x or just 2x. So the way we would write this, okay, and technically this is a balanced method. What's really happening here, and we'll talk about it. Okay, actually I'll write it in.
Oh wait, hold on. Do we always change the operation? So like if it's divide, we change it to multiply.
Yeah.
What would we do for exponent then?
That's called a root. We'll go into that after, okay?
Okay.
So think of it like this, and we'll do two different styles. This style is called the balance method, I guess. So we have 8, and technically it's negative 2x. Actually, this is not called the balance. This is called the elimination style. We do plus 2x on the left side, okay? And we do it on the right side. So whatever we do to one side of an equation, we always do to the other, okay? So I know I told you to switch signs, but let's think of it more like this. The whole goal was to eliminate our negative 2x. So to eliminate it, I would add 2x, okay? So negative 2x plus 2x, what's going to happen here?
The 2's will cancel out.
Yeah, this is a cancellation method. So it's like...
all of it will cancel out.
Yeah, it's like a 0, you would say. Do I need to write in plus 0 there?
No.
No. These are going to cancel out, so we're left with 8 equals, and then on this side we have 10 plus 3x plus 2x, okay? So that's two of the like terms together. On the left side, we want to get all of our constants. So I want to eliminate the 10 from the right side. So if this is positive 10, what operation would eliminate 10? What would? Yeah,
Negative
subtraction. 10. That's right, negative 10 or subtract 10. So we're going to subtract 10, and we still got to write down everything else. Okay, so plus 3x plus 2x. And on this side, it'll become 8, and whatever you do to one side, you have to do the other. Okay, so because we subtracted 10 here, we have to subtract 10 here. Now, 10 minus 10, what will happen there again?
0.
Yeah, 0. They cancel each other out. Okay? Oops. So we have 8 minus 10 is equal to 3x plus 2x. So if you notice, here. Okay. These like terms are on the left, and these like terms are on the right. So now that we've kind of separated our like terms, we can simplify them. We can collect them. So what is 8 subtract 10?
Negative 2.
Negative 2, that's right. So on the left side, we're left with negative 2. And what is 3x
5x.
plus 2x? 5x. Excellent. Now, the original goal, because we're going to redo this again on the left, and I'll show you a whole different method where we move it to the other side. The original goal is it to find what 5x is? It's to find what x is. So now I have to move this 5. Okay, we have to eliminate this 5 over here. And technically this says 5, whoops, that's the wrong thing. 5 times x, okay? What would be the opposite operation of multiplication?
Divide.
So we're going to divide both sides. Remember how we added 2x on both sides? We subtracted 10 on both sides. We're going to divide both sides by 5, okay? What happens here is 5 divided by 5, they cancel out or create a 1. So only x is left on the right, okay? And on the left, I have negative 2 over 5, okay? And I can write that as a decimal as I want. Do you know what it would be?
Negative 0.4.
Yeah, negative 0.4. So,
I'm still doing it. No. Yes.
you got it? Good. So we've done it that way. Let's do it again. This time we'll move the like terms on opposite sides. And we'll do, this one is called more of a, I guess this one's called the balance method. This one was called the elimination style. I can't remember all the names. But here's another way of doing this. Start the equation again. So 8 minus 2x equals 10 plus 3x. Now, over here, actually, this one's called the balance. I'm going to stop giving titles. I don't know what they are. Whatever we did to one side, we did to the other, right? For this one, this is the actual idea where we said the opposites. We're going to use the opposite operations in this one. So this time, I want to move the 3x to the right. So I want my variables on the right, and I want my constants on the left.
You got that backwards.
I do?
You say your variable's on the right, but you point it to the left.
Oh, you're right. Variables on the left, constants on the right. Thank you. So, if I'm going to move 3x to the left side, what would the opposite operation of 3x be? If it's positive 3x here.
Negative 3x.
That's right. So when we move it over, it becomes negative 3x. Okay? So now we'll have 8 minus 2x minus 3x. Okay? Is equal to, and because we moved it over, all that's left is 10. Okay? Now we have the variables on the left. I want to move my constants over. So this 8, and because there's nothing in front of it, is it positive or negative?
Positive.
So if I want to move positive 8 to the other side, what will it become?
Negative 8.
That's right, it's going to become negative 8. So when we go to rewrite this, we'll get negative 2x minus 3x equals 10, and then we subtract 8. Okay? Same idea. I want to show you how similar this is. Okay? This says 10 minus 8. This said 8 minus 10. This is negative 2x, negative 3x. This is positive 3x, positive 2x. So very close, except all the operations are backwards. Okay? And that's just because we went to different sides. It's actually going to all pan out in the end. So, negative 2x minus 3x. Do you know what that'll be?
Negative 5x.
Yeah, negative 5x. And what will 10 minus 8 be?
2.
2. Boom. So, here's the tough part. Negative 5x equals 2. And here, before I did all this, this said negative 2 equals 5x. Very, very close. The goal is still to get x by itself. So what would I do next? You guys have any idea? What would we do next to move that negative 5 to the other side? Since it's multiplying here.
Divide.
That's right. We would divide by negative 5. So when we go to rewrite it again, and I'm writing out every step. You don't technically have to do all the steps. X is equal to 2 divided by, so it's like a fraction, negative 5. Okay? And when we work that out, x is equal to negative 0.4, which is the exact same thing. These ended up being the exact same answer. So we did like 2 different methods, and we moved variables and constants to 2 different sides. It doesn't matter which way you do things, you'll always technically end up at the same answer. It's just whatever you feel most comfortable with.